Now we are going to discuss about the alternating current. First of all, I'll clear you certain points about the alternating current. That alternating current is basically in the form of sine curve. That is, whenever alternating current is produced from an electrical device, the current moves in the form of a wave. That wave is just in the pattern of sine curve or sine graph. So it has got crest as well as trough. The other important feature of the alternating current is that it is moving in the form of crest and trough. One crest and one trough will complete one cycle. So for alternating current, one complete cycle will be taking the time of 1 over 50 seconds. That is, the time period of alternating current is 1 over 50 seconds. But the frequency of alternating current is 50 cycles per second. Whatever numbers I am speaking, that will be mainly valid in India. We find that for our country, the alternating current is having the frequency of 50 cycles per second and the time period is 1 over 50 seconds. Another important thing is that alternating current is responded by an inductor as well as capacitor, but not resistance. So now there are important things regarding the alternating current. Electric currents are of two types. One is direct current, the other is alternating current. Direct current will be a unidirectional current moves in one direction. But when we speak of alternating current, it is a periodic current and its direction is not fixed. It varies regularly after a certain fixed time. Now, direct current, this current flows in a definite direction. The magnitude of current or voltage that remains constant. That is, it does not change with time. So it moves in the form of either simply in the form of crest or simply in the form of trough. So it is not both crest and trough. The magnitude of current or voltage that will remain constant. It does not change with time. The graph drawn between the magnitude of this current and voltage and the time is a straight line obeying Ohm's law. So according to Ohm's law, V is proportional to I, where V is potential difference and I is current. Potential difference is directly proportional to current provided that the physical state of conductor is constant. If I will increase, V will increase in the same proportion. Similarly, if I will decrease, V will decrease in the same proportion. So the ratio of V and I will remain constant, and this ratio will be known as R, that is resistance. Now, in the given figure, we are finding that the graph is a straight line. Moreover, DC current will obey Joule's law of heating effect. According to Joule's law, heat produced in the conductor is given by function I square RT, but this will be in joules. If it is H is proportional to I square RT over J, then heat will be calculated in calories. J means mechanical equivalent of heat and its value is 4.2 joules per calorie. Direct current is produced by a battery or a coil. Its frequency is 0. So, frequency 0 means that it is not forming a sine curve. Direct current is represented by definite direction in circuit. The direct current source is shown in the circuit by the following symbols. That is, plus indicates the positive of the battery and minus indicates the negative of the battery. Now, alternating current, this current does not flow in the definite direction. The direction varies with time. In alternating current, the value of current and voltage does not remain constant but changes periodically. Periodically means after regular interval of time. Normally, we find that one complete cycle of AC will be completed in 1 over 50 seconds, whereas the frequency of alternating current is 50 cycles per second. This current also obeys Ohm's law to a certain extent, not to a large extent. This current also obeys Joule's law. Joule's law states that heat produced is I square RT or I square RT over J, where J stands for mechanical equivalent of heat. Well, this current is produced when coil is rotated in a magnetic field. So what exactly we mean by this statement? Current is produced when coil is rotated in magnetic field. coil rotates. When coil rotates in magnetic field, that indirectly means that it will cut the lines of forces. When it will cut the lines of forces, there will be change in flux, and that change in flux will give rise to induced current or induced electromotive force. The production of this current is based on electromagnetic induction. So what is electromagnetic induction? We have discussed earlier. It is a phenomena in which, due to change in flux, there is formation of induced current or the induced voltage. Moreover, the frequency of alternating current is zero. That is, crest will be positive half and trough will be negative half, and if you algebraically add them, it will become zero. In alternating current circuits, the direction of current is not indicated. The reason being, the current is not fixed, it is not constant, it varies according to time. Source of AC is represented by the following symbols. So, symbol is indicated. We take a curve, and that is very mild crest and trough is indicated in the figure. Only periodic change is necessary for alternating EMF or current. According to the waveform, there can be many types of waves. Some of them are indicated as follows. Like triangular waves, they are used in electronic circuits, like in PN junction transistor, in diode walls, in triode walls, or PNP transistor or NPN transistor. Second type is square wave, and square wave will be also used in the electronic circuits. Then sinusoidal waves. So sinusoidal waves are in the form of crest and trough. So crest and trough is indicated on x-axis, whereas voltage variations are indicated on y-axis. Sinusoidal wave is the simplest alternating EMF or current. Its value changes simple harmonically such that the type of change or such type of change can be represented by sine or a cosine function. So sine function will be in the form of crest and trough, and cosine function will be in the form of that is crest and trough, but it starts from that is trough, and then further we find again the crest and trough will exist on this function also. Now, equations of the alternating EMF and alternating current and their graphical representation. So, what we find is in the figure, a coil is indicated, that is a dark shade, and B is the magnetic field, the direction of magnetic field or the lines of forces, and theta is the angle between the normal and the direction of magnetic field. So, normal and angle theta, that is when we speak normal, means theta is 90 degrees with respect to coil. So, whenever coil will rotate in this magnetic field, the lines of forces will cut, and as a result, the magnetic flux will change, and that magnetic flux, change in magnetic flux will give rise to induced current and induced electromotive force. Now, this caption is given like that. When a coil is rotated rapidly in a strong magnetic field, magnetic flux linked with the coil will change. As a result, an EMF is induced in the coil and induced current flows through the circuit. The magnitude and direction of the induced EMF and current change with orientation of coil. Such type of current is called alternating current, and voltage is called the alternating voltage. Alternating current or voltage becomes zero two times in one cycle. When we use the term one cycle means one crest and one trough. As it is mentioned that alternating current or voltage becomes zero two times. So when the voltage or current starts, it will be from the zero, and then it will rise to maximum after tracing 45 degrees or pi by 4 angle. Then for the next pi by 4 angle or 45 degrees, again it will drop to 0. So first of all, the current will rise from 0 to the peak value, and then from peak value to the 0. So it is 2 times in one cycle and is maximum 2 times in one cycle. The time taken in completing one cycle is called time period, that is represented by T, and time period is always inverse to frequency. So the time taken in changing the current or voltage from 0 to maximum value or vice versa is T by 4 seconds. So in T by 4 seconds, if we will add T by 4 times, it will become T. The time period of alternating current is 1 over 50 seconds and the frequency is 50 cycles per second. This statement varies from country to country. In different countries, specifically in American dominating states, we find that the value of the time period and frequency is not as it is in India. They can vary up to extent of 160 cycles a second, or time period can be up to 1 over 160 seconds. That is, their operating machines are much faster as compared to the machines used in India. The number of cycles completed in 1 second is called the frequency of the alternating current or voltage. So alternating voltage or alternating current has a frequency 1 over F or 1 over N, it is taken as F or N, and it will be 50 cycles per second. If a graph is plotted between the induced EMF and induced current, the angle of rotation of the coil, then for one complete rotation of the coil, the curve shown in the figure is obtained. From this, it is found that variation of alternating voltage or current is periodic. That is, with time, the direction of current varies with time, similar to sine curve. So, alternating EMF or voltage or current is called sinusoidal current. Sinusoidal means moving in the form of sine curve. When the curve is shown at the climax top, it will be the peak value, and when it is shown at low point, it will be the minimum value. At any instant t, the alternating EMF E and the current I can be represented by E is equal to E naught sine omega t. In this function, omega will be phase angle, and this can be given by function that is omega is equal to 2 pi n, or it will be 2 pi over t. E stands for instantaneous value of electromotive force, or RMS value of electromotive force, or effective value of electromotive force. Wherever we write E naught, that is called peak value of the electromotive force. So whenever we calculate peak value, that is E naught, the function for E naught will be root 2 times of E. Root 2 times of E. Similarly, I is the instantaneous current, I naught is the peak value of current. So if we wanted to relate I and I naught, we will find I naught will be root 2 times of I. But suppose that we are interested to find simply E, then it will become E naught over root 2. E naught over root 2 can be further simplified by multiplying and dividing by root 2, and we will get a different numerical value. E and I are the instantaneous values of EMF and current. E naught and I naught are maximum or peak values of EMF and current respectively. Omega t is a phase angle, or it is angle covered by the coil in t seconds. The value of E naught and I naught in terms of coil parameters are: the peak value is given by function basically B omega A for a single turn coil, but for n turns coil it should be N into B omega A, and I naught will be N B omega A over R. N is the number of turns in the coil, B is the magnetic intensity or magnetic field, A is the area of coil, and R is the resistance of the circuit including the coil. If the frequency of AC is N, period is T, then omega, that is phase angle, will be 2 pi N or 2 pi over T. Thus, the equations of AC voltage and current can be written as E is equal to E naught sine 2 pi NT, or it is E naught sine 2 pi by T into T, where N is replaced by 1 over T. When we write T capital, it will be time period, and when we write small t, it will be instantaneous time when the wave is moving. And similarly, the explanation for the instantaneous current, that is I is equal to I naught sine 2 pi NT, that is I naught sine 2 pi over T into T. Small t, instantaneous current, or T is the time, instant of time when the current is moving, and capital T is the time period of the sine curve or the alternating curve.